Okay, today's lesson is going to be angle proofs. It's going to be really similar to segment proofs. We're going to have a few postulates and theorems that we're going to use a lot. And so let's start. When we do angle proofs, there are three big postulates that we're going to use on this first lesson. There's actually going to be several lessons on angle proofs. For this one, we're going to use the angle bisector definition. We're also going to use an angle addition postulate. That's similar to the segment addition postulate. And we're going to do the perpendicular lines form a right angle. And so those are the three main postulates related to an angle that we're going to use today. And of course, like always, we're going to use a lot of substitution or the transitive property in addition to those three main postulates and definitions. So let's get started, see how this works. Okay, so the first one, what we have is we see that we have an angle that's broken up by two smaller angles. And in this case, we can see that these smaller angles are actually congruent to each other. Take a look at those hash marks. So in this case, what we're dealing with is an angle bisector. And when we do the proofs, we may see this in two ways. One of them is they may give us the fact that these two small angles are congruent by either putting hash marks or making a statement that ABD is equal to DBC. So either way that they do it, we're going to be able to make the conclusion that BD is a bisector, or it may not just, or we may just be able to say ABC is just strictly bisected and not worry about the ray itself. And of course, the reason for that would be the angle bisector definition. Now, kind of opposite of that would be, let's say that they tell us that BD is a bisector. If that's the case, then we can draw the conclusion that the measure of the two angles it creates are equal. So the measure of angle ABD and the measure of angle DBC would then be equal to each other, and we can make that statement. Again, that's due to the angle bisector definition. Okay, the next proof, or postulate that we're going to have, is the angle addition. And you can see that when I look at this, there's nothing related to congruent angles here. So I can't say that angle ABD is the same as DBC. So what I can say is that the measure of this small angle here, ABD, plus the measure of the other small angle, DBC, is equal to the measure of the whole angle. And that's the angle addition postulate. So we'll use that a lot. Once again, the measure of the two smaller angles added together equal the measure of the big angle, and there's not going to be anything related to congruence in there or a right angle. Okay, the next one is a little bit more complicated, and what we see is we have two perpendicular lines. It tells us they're perpendicular. QR is perpendicular to RT. And here's where it gets a little complicated. If we know that we have perpendicular lines, the conclusion that we can make is that the angles it forms is a right angle. So QRT would be a right angle, and QRS would be a right angle. Notice I didn't say they were equal to 90 degrees, because that's a separate definition that I have to use. So anyway, perpendicular lines form right angles, and that would be something that I could use. Now let's take that a step further. Okay, so taking that a step further, remember, if I have a perpendicular lines, then I can say that they form a right angle. Now I have a separate definition that says that if I have a right angle, that then the angle it forms is 90 degrees. So that would be a separate definition. That's called the definition of right angles. Then once I know two angles are 90, I can say they're congruent. Now we have one new theorem that we could use, the way I don't think we'll be using it today, would be that if I have perpendicular lines that I know form a right angle, I can say that those right angles are congruent. So I can skip the part that says that they equal 90 degrees. So once again, that's a new theorem. Perpendicular lines form a right angle. Then I can say that any right angles are congruent to each other. That's called the right angle congruence theorem, and I don't think we'll be using that today. So let's do a couple proofs. The first thing we have here is, take a look at these angles, and it says that the measure of angle EFG, so that's this angle EFG, plus the measure of angle DBC are equal to the measure of angle ABC, and there was a mistake made in the notes. So notice there's no right angles, and that they're not showing that there's a bisector, so this would be an angle addition kind of problem. So the first thing I'm going to do is I'm going to restate the given, and I did that. Then, by the angle addition postulate, I could say angle ABD plus the measure of angle DBC is equal to the measure of this big angle right here, measure of angle ABC. Now then, since you can see that here's my given, and the given said that these two angles added together equals the measure of angle ABC, and what I just saw from the angle addition postulate was that two different angles add to be ABC. Well, since both of these, look, those are ABC there, that these two must be equal to each other. So that was my third statement, is by using substitution, I took this measure of angle ABC and I substituted this in for it. Then what you can see is when I set those equal to each other, I have the measure of angle EBG plus the measure of angle DBC, that's exactly what I had up here, is equal to the measure of angle ABD plus the measure of angle DBC. So there's my statement there, and that was by substitution. And now take a close look at this. What you can see is I have angle DBC in both ones, so if I subtract angle DBC from both sides, I get the measure of EFG is equal to the measure of ABD, and that's what I set out to do. So once again, that was by the subtraction property of equality. Okay, next proof. We are given that AB, that's this line here, and CD are perpendicular. So I rewrote that as a given. Now, because they're perpendicular, I can say that DCB is a right angle. Perpendicular lines form a right angle. So that was my next statement, and that was by the definition of perpendicular lines. And now that I know that these lines form a right angle, so this is a right angle, then I can say that that angle is actually equal to 90 degrees. That's a separate statement. Once I know it's a right angle, then I know it's equal to 90. So I'm going to say the measure of angle DCB is equal to 90. That's my third statement. Now I'm going to also use the angle addition postulate, because what we're trying to prove is that the measure of angle 1 plus the measure of angle 2 is equal to 90. Well, the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle DCB. So I wrote that as a separate statement. Do the angle addition postulate, 1 plus 2 equals DCB. And because I'd already proved that DCB is equal to 90, I'm able to take this DCB and replace it by 90 degrees, which is what I did here. So the measure of angle 1 plus the measure of angle 2 is equal to 90 by substitution. There's 90 substituted in for DCB, and I've proven that. Okay, the last proof that I have is, notice again, I don't have a 90 degree, I don't have a bisector, so this must have something to do with angle addition. And so let's get started. It says that the measure of angle 1 is equal to the measure of angle 3. Here's angle 1, angle 3, they are equal to each other, so I wrote that as my given. Now that I'm going to use the angle addition postulate, I'm going to say this angle right here plus this angle right here is equal to the big angle DBC. So the measure of angle DBE right here, which is angle 2, plus the measure of angle 1 is equal to the measure of DBC. So there's what I have from the angle addition postulate, statement 2. And now then, notice that that particular statement said the measure of angle 2 plus the measure of angle 1 is equal to DBC. Well, I know that angle 1 is really equal to angle 3, so by substitution I pull angle 1 out and I put angle 3 in. So now then I have the measure of angle 2 plus the measure of angle 3 is equal to the measure of angle DBC. Alright, so now let's use another angle addition postulate. Let's say that the measure of angle 2 plus the measure of angle 3 is equal to the measure of this big angle, EBA. So I wrote that out as an angle addition postulate right here. And my next step, notice what I've created. I've created the same thing on the left side for these two statements. And because these are the same, that means I can substitute in the DBC, and these two have to be equal to each other. So by substitution, since these two are the same, the measure of angle DBC must equal the measure of angle EBA. And I wrote that out, and that's by substitution. So that's my last proof. Now, that was a lot of information, and it was fairly quick. But it's really related a lot to the segment addition. Notice we had three postulates that we used, something called addition. We used the bisector, and we used the perpendicular. And every problem I had to analyze which one of those was going to be my main one. And then I used substitution a lot. And so it's real similar to the segments. You may have to watch this video again, but anyway, it's time to start your homework, so get going.